Question number 71. Addition of inert gas at constant pressure in equilibrium 2SO2 plus O2 to give you SO3. This is the reaction at which equilibrium is maintained, and we just have to find out the effect of addition of inert gas at constant pressure in the given equilibrium. The first option, it decreases the volume of gaseous mixture. It decreases the total mass of gases. This is the second option. Then shift the equilibrium in backward direction and increase the partial pressure of SO3. So one thing you should always remember, that if you add inert gas at constant pressure, then definitely in that case volume is increased. And if volume is increased, it means the first option that says decrease the volume of gaseous mixture, it is wrong. Now, if volume is increased, then definitely the total moles of gases would also be increased. So the second option is also wrong, that says decrease the total moles of gases. Further, shift the equilibrium in backward direction. Now, if you are adding inert gas at constant pressure, it means volume is increased. So definitely the equilibrium will shift in that direction where the number of moles are increased. It means the equilibrium will shift in backward direction. And if it's shifting in backward direction, then third option that says shift the equilibrium in backward direction is correct. Now, it increased the partial pressure of SO3. If equilibrium is shift in backward direction, it means in that case definitely the moles of this SO3 are reduced. If its amount is reduced, its mole fraction is reduced, then definitely its partial pressure should be reduced, not increased. So this is also wrong. Which option is only correct here? Option 3. Now, after this, let's take question number 72. For an endothermic reaction, the correct graph is, I'm just going to tell you the relation between Kp value and the temperature. There's a relation that states log Kp is equal to log A minus delta H upon 2.303 RT. This is the relation. And now, if you are plotting the graph between log Kp and 1 upon T, this you are taking at x-axis, this you are taking at y-axis. Let's compare this with the equation of straight line, that is y is mx plus c. It means this log A is representing intercept here, while this m is the slope of this graph, and that slope is m, and that is equal to minus delta H upon 2.303 R, and this slope is negative. This negative slope is only given in option 3. You can clearly see here, this log Kp is plotted with 1 by T, and you are getting this graph where this is the intercept and the slope is also minus delta H by 2.303 R. Negative slope is given here, and this is the correct answer for this particular question. After this, let's take next question. Question number 73. Pair of solutions which cannot form basic buffer is. What is basic buffer? If we talk about the basic buffer, this is prepared by mixing weak base and the salt of that weak base and a strong acid. Now in this question, you just have to find out that pair of solution which cannot form basic buffer. It means we have to check the options here. The first option, it says NH4OH and KOH. If you make these two, first is NH4OH a weak base, while this KOH is a strong base. Mixing of these two will not result in the formation of a basic buffer. Further, NH4OH and HCl, if you mix these two, NH4OH is the weak base, and when these two are mixed, definitely there is a formation of ammonium chloride. That is the salt of a weak base with strong acid, that is HCl. It will form basic buffer. NH4OH and ammonium sulfate. Yes, this is an example of the pair of solutions which can form basic buffer because weak base is there and the salt of that weak base with strong acid, ammonium sulfate, is also there. So this is an example of that. Further, NH4OH and H2SO4, if you mix these two, NH4OH, a weak base, and H2SO4, when mixed with it, it will form ammonium sulfate, the salt of that weak base with a strong acid, and that's why it will form a basic buffer. And on that basis, the only pair of solutions which cannot form basic buffer is given here in option 1, and you will choose it as the correct option. Now after this, question number 74. Among the following, which gas will show maximum negative deviation at moderate pressure? So if we talk about the negative deviation, this is shown by those gases which have intermolecular attraction. More the intermolecular attraction, more would be the negative deviation would be there. And if we talk about carbon dioxide, this is that gas which show maximum intermolecular attraction. And definitely due to that, it will show maximum negative deviation also. So I'm just going to choose this as the correct option. After this, let's take next question. Question number 75. At 300 Kelvin, the most probable speed of gas A, molecular weight is 36 U, is equal to root mean square RMS speed of gas B. The molecular weight of gas B is. Here, the most probable speed of gas A is equal to the root mean square speed of gas B. The two things are equal. And we know that this most probable speed of a particular gas is equal to root 2RT by the molecular mass. Of that particular gas. And this should be equal to root 3RT by MB. Why? Because this is the formula to calculate root mean square speed. Now let's compare these two. We can write it as MA by MB is equal to 2RT by 3RT. So simply we can write it as MA by MB is 2 by 3. We have the molecular weight of A, that is 36, by MB is equal to 2 by 3. So what would be the value of MB? MB would be equal to 36 by 2 into 3. So it would be 54 U. And this is here given in option 3. That's why I'll choose this as the correct answer.